Okay, so let's we'll get into this last kind of chapter on landfill disposal in terms of the municipal solid waste management part of this particular course. So if you remember from in the beginning, we had a big overview where we had a first week, and part of the second week we looked at a big overview where we talked about the landfill disposal. I also showed you from a global perspective how the landfill is still being used in many places around the world. Whether we like it or we don't like it, landfills are going to stay there. So as an engineer or as a waste management professional, we need a good understanding of the landfill. Even in the Indian context, if you look at, we do want to make we do want to have waste to energy plant. We spend a lot of time on waste to energy in last several videos. We want to have composting or anaerobic digestion, but at the end of the day, even after doing all these treatment systems, we will have some residual which needs to find place in a landfill, which you cannot really recycle, which you cannot do anything with that. So maybe in future our children or grandchildren may be able to do something with that, but right now we don't have technology, we don't have know-how to do anything with that. So those kind of material cannot be just thrown anywhere, so it needs to find a place, and that place is a landfill. And so we need to build, in the Indian context also, we need to build landfills, and there is a concept of regional landfill is also coming up. I have been involved with looking at DPRs of several ULBs in the country, and where we reviewed the technical merits of the DPR, and I also helped in preparation of some DPRs, and they're all were in terms of the Swachh Bharat mission and this SPUR and those kind of organization. Right now the focus is more on making the land like a regional landfill. So rather than say Kharagpur town where I am right now, it's Kharagpur will not have its own landfill. Maybe Kharagpur and other nearby cities, nearby towns will get together and make a one regional big landfill, and which will have the waste coming in, the non-recyclables, non-combustible, non-organic waste coming. When I say organic, it's the biodegradable, they're coming to these landfill sites. So that's the kind of the thought process behind it. Of course, we need to make it happen. So in this particular set of videos starting from now and probably a few after this, we'll be focusing on this landfill disposal. What is a landfill? How the landfill is made, what are the challenges, what are the design aspect, what things we need to consider. Those things we'll talk about in this set of slides. So let's get started, and so we have in kind of just a quick recap. We started with the collection, we looked at what is in the waste, the composition, the quality, characteristics, then the collection part, transfer and transport, treatment in terms of the biological treatment, thermal treatment, those things are done. Now this chapter is say that after all the treatment is done, whatever is possible, the residual has to go in an engineered scientific like a scientific landfill which is engineered design. So it's that's what we will be looking at in this particular case. So landfill, it's a concept in early 20th century. So it's basically an area of land which is you deposit some solid waste, and you has a noticeably change on the surface elevation. So basically you are making a small hill kind of that. So that's what is landfill is all about. Why to use a landfill? If you don't use the landfill properly and then you dump the waste along the side of the road, as you can see in this particular picture, that creates lots of nuisance. The air, because of there is no gas collection system in here, you have this emissions going into the atmosphere. So that is also a problematic stuff. Then surface water can get contaminated, and if you have a rainwater percolating through and may go either into the groundwater, or it can also go in a surface water nearby. So there are a lot of problems if improper management of waste. You go throughout the country, like in India, you find so many dump sites, like a small and big, many dump sites at several places within a town. So those things creates lots of nuisance. It creates a problem in terms of the air pollution. It creates problems in terms of course, the aesthetics and the cleanliness that is there. It breeds different kind of like mosquitoes and other things, and those creates a health problem. We have stormwater drains gets choked because of this waste from these dump sites getting into our stormwater drain. With this plastics in the stormwater drain chokes the stormwater drain, and then we have this rain event. If you remember, just in this particular rainy season, we had floods in Ahmedabad and a lot of in part of Gujarat, part of Rajasthan, and even West Bengal, Assam, and many places. Of course, there is too much of a rain, so we had this flood. But in the urban centers, what is happening today is improper management of waste is also if I say that improper management of waste is responsible at least partly for the flood situation. You may not. It may not come to you directly, but if you just think about that, say if our stormwater drain gets totally choked up by these plastics and other material, where the water will go? Water will start ponding up on this stormwater drain on our streets, and then that leads to all the water logging and all those things happening around it. And that's, of course, it's a temporary like a flood kind of problem, but then also leads a problem if the water gets on the surface of the road for a long period of time, the road gets damaged. Just during the rainy season, right after we had a 3-4 days of big rain in this particular area, and after that, when I was going towards the airport, Kolkata airport, I saw the road is already part of the road is already damaged. So it's just improper management of waste is partly responsible for road damage as well. So things are all connected. So we need to make sure anything which cannot be treated. And I'm also of the view that even if you don't have the treatment system in place and you have an engineered landfill in place, let's at least put it in an engineered landfill. Although I advocate that we should have treatment system, but in an event like that where the treatment system is not up and running until now, but we have a good engineered landfill, let's at least put in a good engineered landfill so that we don't have any other problems associated with improper management of waste. See another like a scenario where the waste not being managed properly. This is a dump site. As you can see in this particular picture, dump sites, a lot of animals in there and then all this leachate. This is what you have, the leachate, very nasty material, and these animals are consuming this stuff, and they will also get sick, and they will carry some germs, and then they will carry germs in our residential areas as well. So what are the potential landfill problem? Landfills, they do present problem in terms of the spread of disease. There is a spread of disease, there is a smell problem, fire problem, and those things can be controlled by sanitary landfill technique. You can do sanitary landfill stuff for that. Then you can have contamination of groundwater or gas emissions that is controlled by modern landfill design. So those things are done by modern. We'll have in terms of the landfill design, as you will see in this particular section when we in this or subsequent videos, where this groundwater like a leachate collection system, which is the groundwater to prevent the contamination of groundwater, the leachate collection system and the gas collection system. Those are actually very, very good. Those are very essential component of a landfill design. And those of you, it might be that IIT Delhi, as part of this NPTEL program in this particular time as well, Professor Manoj Datta from IIT Delhi is offering a course which is running parallelly, which is more talking about the geo-environmental stuff. And there also he's talking about landfill design. In fact, I am registered in that course just to see what kind of material he's covering. So it's the geo-environmental aspect, because the landfill design is a geo-environmental work. It's a lot of geotechnical aspect goes in here, and as well as the environmental. And so Professor Datta, basically being a geotechnical engineer, he's focusing more on the geotechnical aspect, and in this particular module we are focusing more on environmental aspect. So if you have registered both the courses, actually you are getting a big picture. You're getting a much bigger picture of both like a more detailed picture of landfill design. So in terms of sanitary landfill, it could be excavated and filled. You can even excavate and fill it. You can make some hole. It all depends on how low is the groundwater table. If the groundwater table is very high, you will probably start at the ground level. You will not dig and go down. But if the groundwater table is low, what you can do, this is the surface. That's the surface of our surface. You kind of dig a little bit, and then you start from the lower side. This sketch is not to scale, but don't worry about it. So you go down and you start from here, and then the landfill goes up along that. You can fill existing depression. If there are some existing depression, you can use that. That can be used over here. It can be built up from the ground, or it could be combination of all these as possible. Then we do operate as a control. What kind of control? You use cover soil. Why to use cover soil? Landfill, at the end of the day, this engineered landfill facility, when they are operated in a scientific way, at the end of the day, say if the landfill works from 8 a.m. to 5 p.m., at around 4 o'clock, it will stop getting any more new garbage. So the trucks coming into the landfill, they know that if I reach there after 4, I'm not going to be able to put this garbage into the landfill today. We have to wait overnight over there. So many times actually they don't come. But up to 4 o'clock, say they will accept the garbage. After 4, they put a layer of daily cover on top. Why this? Because if you, as I said, I think earlier, if you want to really watch birds, go to a landfill. And because the birds gets attracted with all this food waste and other stuff, even if you have a source separation and all those things going on, still you have some of these material in the landfill, the waste which is dumped into the landfill, which attract these birds. And so to reduce those attraction, and then also to control the smell, otherwise things will smell. So you put the thing on top, and it also helps in terms if you have a film plastics and those kind of material, in the case of wind, they will start blowing away. So if you put a layer of cover soil on that, it tries to keeps it down. And then also it it does help in terms of any rodents, vectors, and those things trying to get attracted towards this waste. So we use cover soil. We can excavate cell if we have to do that. Like we can go down and do this as cell. Compact the waste. Why the compaction? Compaction helps in improving the C and 5 values. Remember that from your soil mechanics class, because landfill is as I said, it's the slope. There is a slope of the landfill. So the landfill typically, if you look at the cross section of a landfill, it's something like this. So you will have the bottom, and then you have a side slope, then you have a top, and then you have a side slope here as well. Both sides the slope will be the same. May not be in my picture, but essentially this is how this landfill will look like if you look at a cross section of the landfill. So there has to be a structural stability of this landfill structure. So otherwise you will have the failure. You will have a landfill failure. So that's to prevent that. We need to compact the garbage. So because to make it compact, make it close, so that our C and 5 values are good, and then the landfill does not collapse on its own. And then the control access just to make sure that things doesn't, because you produce methane gas, things can catch on fire, it may explode, and there are issues of if people can. There is history of that it was the dead bodies were dumped there, and so that's why you need a control access. You need to fence it, keep it closed, and have some sort of control going on in terms of you have a camera going on or something so that you can monitor the facility. So modern landfills are engineered structures. So they are not like a dump site. They are engineered structures. They are designed to contain the leachate and minimize release of pollutants from the landfill. So you have to contain the leachate, and at the same time you are minimizing the pollutants coming out of the landfill. So when you are minimizing the pollutants, so you have to take that. If the leachate is collected, so we have to remove the leachate, and if the gas is collected, we have to remove the gas, and we have to come up with a system to do that. So leachate is the liquid or the wastewater. It's kind of industrial wastewater. So if you have taken a wastewater course, leachate, all the treatment and leachate quality, all those things are pretty much similar. And how it gets forms when we have the rainwater, because when the landfill is working, landfill is accepting the garbage, it's exposed to air, exposed to the natural environment. So you will have the rainwater percolating through the garbage and then coming down because of gravity, and that becomes your leachate as it crosses that. When the waste degrades, if you remember from the anaerobic digestion chapter that we talked about, when the waste degrades, moisture is also produced. Moisture is one of the byproduct of waste degradation, especially in anaerobic environment. So that's moisture becomes part of the leachate. and then it travels through the like solid waste, and that's so leachate can migrate. So as so if you had, as I was telling you in the previous slide, if you, this is the landfill, so just to make a small cross section of a landfill. So if this is our landfill, now the leachate is there, leachate will have a tendency to go down, and then if we have a groundwater table somewhere here, it will try to go and contaminate the groundwater. But our goal is not to have it happen. So what we'll have a leachate collection system at the bottom over here on top of the liner. So we'll, and I'll show you a better sketch of that. So we have a leachate collection system which removes the leachate. So leachate can migrate, resulting in contamination. So we cannot let that happen. So leachate and it contains different chemicals depending on what is in the solid waste. So depending on type of solid waste, you will have different chemicals coming out, different chemicals present there. Then other thing is the landfill gas. So those are the two major stuff: leachate, landfill gas. Landfill gas is primarily methane and carbon dioxide, and it results from the anaerobic digestion of biodegradable solid waste. So that's what this gas is produced. Typical, and then there are some regulatory requirements that location wise you cannot be too close to airport, as I said, because it attracts lots of birds. You cannot have closer to a wetlands because of any sensitive species, fault lines, unstable areas, endangered species. So those are kind of typically normal stuff for that normal requirement. Then you need to have liners, because if you are keeping leachate into the landfill, you need to remove the leachate. So the liner keeps the leachate and migrating out of the landfill. Leachate must be collected. So for the liner, we have the low permeability layer. Liner is basically not let the water pass through. So you can have a compacted soil, which is a clay. It could be a geomembrane, which is a plastic, or a composite of both. So many times you see especially composite of both. Liner will keep the leachate from migrating out of the landfill, and so it's basically becomes an impervious layer. It's like a polythene bag, huge polythene bag at the bottom, and then the leachate will start ponding up. So we cannot let the leachate pond up too much, because as the pore water pressure will build up, our slope stability problem will come. So we need to collect this leachate and remove it within a set of pipes, and that's what is essentially is the leachate collection system. So there are, in terms of the liner, there are one liner consisting of compacted soil or geomembrane. That's the single liner system. You can have a composite liner where they consisting of both compacted soil as well as the geomembrane in intimate contact. That's you see more popular. Then there are double liner. So we have a liner system with low permeability barrier, and then in between we have a leak detection system. So upper and lower components are either compacted soil, geomembrane, or composite. So either of those things could be there. So this is a typical subtitle D liner. Subtitle D is basically municipal solid waste. This term subtitle D comes from US EPA. So it's a US EPA. They call it subtitle C and subtitle D as part of the RECRA, which we talked about in the very beginning of this course. RECRA is the Resource Conservation Recovery Act. So that's the Resource Conservation and Recovery Act. It's the RECRA. That's from the RECRA we got the subtitle C and subtitle D. Subtitle C was for hazardous waste, subtitle D is for solid waste, municipal solid waste. So as per that requirement, and we follow in India pretty much the same requirement here as well, this is what is the typical liner requirement for a municipal solid waste landfill. So here we have 2 feet of compacted soil, then we have 60 mil HDPE geomembrane. So it's 60 mil, 1 mil is 0.001 inch. So it's so 1 mil is 1. So it's we can find out what is the. So it's essentially not too much. It's around like points. It's around 6 millimeters. So it's less than a centimeter thickness. So then you have a 2 feet of drainage material. That's which is there on the top. So here the point is, if the leachate tries to go through, liner will protect it. If somehow the liner has this breakage because of this clay layer, because of the clay layer here, with a permeability of less than 10 to the power of minus 7 centimeters per second, the water will not really pass through, and it will take a long time to pass through. On top, if you are putting this barrier layer here, so that means the water will start ponding up. And so we need to remove the water which is ponding here, which is essentially the leachate. So we put a 2 feet of drainage material. So that's your 2 feet of drainage material, 2 feet of drainage material here, and that drainage material will essentially help in terms of all the leachate, which will be a set of pipes on this side. So the leachate will go into this set of pipes. Here will be a perforation, and these pipes are actually somewhere like this. It's kind of if you look at a section, cross section, the pipes are going this way into the landfill, and I have a better picture for that to show you. So those pipes will collect all the leachate and take it outside the landfill. So that's how the whole system works. So that's for like a MSW landfill. Then for subtitle C, which is the like a hazardous waste landfill, which is a double liner system, we have again 2 feet of drainage material for same concept for removing the leachate to design to, and we have to have less than 1 feet of head on the liner. We don't want too much of head on the liner being built as well. We want less than 1 feet head on the liner. Then we have HDPE geomembrane, one HDPE geomembrane, other HDPE geomembrane. In between we have the leak detection system. Yeah, so we have one HDPE geomembrane, then you have the second HDPE geomembrane. In between we have this leak detection system that you see in the middle. So that's the leak detection system. We call it like the GeoNet. So that's so then the 2 HDPE geomembrane. So even if the liquid passes through the first one, it will be caught over there. If it doesn't get caught, it will still have the other geomembrane to not let it pass. Even if it passes through that, then we have this clay. Again, here, since the hazardous waste, more requirement, 3 feet of clay, and then K is same, less than 10 to the power minus 7 centimeter per second. So that's also called the double liner system. So that's our double liner. The earlier one was a single liner system. So there are different materials could be used. The most popular one in terms of the liner is HDPE, high density polyethylene. So that is what is used in most of the places in terms of the liner requirement. So that's is done for that part. And then what controls the head on the liner? The liner slope, the slope of the liner, the pipe spacing, LCS, hydraulic conductivity, the leachate collection system, hydraulic conductivity, impingement rate. Impingement rate is the rate at which the liquid is coming to the leachate collection system. So that's the impingement rate. So those are the more common, like liner slope, the spacing of the pipes, because the higher the spacing of the pipes, more will be the head on the liner. Because if we are looking at, say if this is kind of on one of the, just 1 second. So if we are looking at, this is our kind of one of the section, like a part of the landfill at the bottom. So if we have one pipe here, one pipe here, and if we have one pipe, say if we have more the space between the pipes, more of the tendency of the water to pond through. If they have less space between the pipes, water will actually go away quickly. So more the pipes, less the head, which is kind of obvious. Liner slope, in terms of the slope, that also lets the water coming in. Hydraulic conductivity of the leachate collection system. So whatever is the material in this area, this is the leachate collection system area, whatever is the material in this area, if it's of a high permeability, and then the water will pass through quickly through that and goes to these pipes and get out of the system. So that's the hydraulic conductivity of the leachate collection system is important. Then the impingement rate. Impingement rate is the rate at which the liquid is actually coming to this area, to the leachate collection system, and what rate it is coming. It also will depend on the type of waste that we have, how much moisture there in the waste, how much, if there is a rain event going on. So all those different things will kind of factor in. If the landfill is still accepting garbage, it is open to the atmosphere, so rainwater can come in. So those things will kind of influence in terms of head on the liner calculation. And we can do that. There is actually a model which is known as the HELP model, hydraulic evaluation of landfill performance. So that model is used to kind of do this leachate collection, how much leachate production prediction. So we can, I'll introduce you to that model towards the end of this particular chapter. So then we have a geosynthetic clay liner, which is a soil component, which is on dry, it's a soil component, dry bentonite contained in a fabric affixed to a geomembrane. So that's also, it's another liner system. So let's look at some pictures of how a typical landfill is constructed. And then so this is this place, if you don't have the clay in house, so you bring the clay from outside. So here the clay is being driven to the site. So this is a bentonite clay. The clay is being dumped onto the site. So once the clay is dumped, you start compacting. because we have to have remember from the liner requirement, we need to have 2 feet of clay, permeability less than 10 to the power of minus 7 centimeter per second. To achieve that permeability and to have this 2 feet thickness, you bring this clay, you start compacting them. And when you are compacting, as you can see on this particular picture, while the compaction is going on, this gentleman from this truck is spraying water. And those of you who are civil engineers should immediately get these things should stick in your head immediately, that why this water is being added. And if you think about that, why we need this water when we are trying to do the compaction. Remember from your soil mechanics lab that when you did this Proctor compaction test, so there what you did, you had an OMC curve. What was the OMC curve? Optimum moisture content. So if you remember from that, we had where you had the effective dry density, the dry density here, effective dry density with the moisture content, and the graph was something like this. And that's your maximum dry density and at a certain moisture content. So what this gentleman on the truck is trying to do is trying to find this particular point, this moisture content, and he knows how much moisture is there in the clay, and then he's adding enough water. So his speed of the truck is kind of trying to in such a way so that the water added in this area reaches towards optimum moisture content for the clay. So that's the typical OMC curve that you generated if you've taken the soil mechanics class. So again, everything that you do, like in landfill design is specifically geotechnical concepts are very, very important. So we use those geotechnical concepts a lot in landfill design. So let's look at some more how this construction is done. And so once it is compacted, this is like a final phase. But since if you put the liner on top like this, the liner will be undulated because it's not as smooth, so there will be a lot of undulation there. So to avoid that, what we put a fine layer of clay on top. So you see the fine layer of clay, very smooth layer of clay. On top of that, you have some of the rolling is going on. It looks like very similar to the roller they use for the cricket matches. If you remember, in between the innings they roll the pitch, so it's kind of looks the same. Then you lay the liner on top, and you see the liner, you can see this is the HDPE, high density polyethylene. Since the liner comes in a certain sizes, so you need to weld them as well, so the liner is being laid. This is again another picture. You see the clay at the bottom. On this particular side we have clay at the bottom. This is you can see the clay here in the bottom, and then this is you see the clay at the bottom and then the liner on top, and then we have another same picture from a distance. The liner is still being laid, and the liner is totally laid for that particular cell now. And since this liners comes in a specific size, we have to weld them. We have to make this entire area as this entire area will be one piece of this HDPE. So we have to make this welding along all these edges. So that's how this like the whole things are done. So I will continue this discussion in the next video. So where we'll look at how from the leachate collection system and the gas collection system, how to predict the leachate production, how to predict the gas, and then towards the end we'll also do, maybe in subsequent videos, we'll also do some math in terms of the basic landfill design. And the detailed landfill design is not part of this course, and hopefully in future we'll try to offer a course just on landfill design, because that itself is a full-fledged semester long course, because you have to look at a lot of different information there. So with that, again, I think that you guys are enjoying this course. Keep the discussion board active. I see some activity going there. We would like to have more activities on the discussion board, and any questions, ask us. We are here to help you, and that's the whole goal of this course, is to make more and more people technically aware of municipal solid waste management, which is unfortunately not that much. It's lacking in Indian context. It's lacking globally as well. As I have worked in many countries around the world, I see that understanding of waste management system is not as much as you would see in a water treatment or wastewater treatment plant. So we need to increase the capacity building we need to do, and this course is part of that. So okay, so thank you, and I'll see you again in the next video.